In this video, we will discuss graphical symmetry. In particular, we will define and discuss symmetry about a point and symmetry about a line. We will start by defining these two types of symmetry. Points A and B are symmetric about a point, provided that point is the midpoint of the line segment joining A and B. Points A and B are symmetric about a line, provided that line is the perpendicular bisector of the segment AB. Consider the following illustration. The given points A and B are symmetric about the point P, where P is the midpoint of the segment AB. Similarly, points A and B are symmetric about the line L, where L is the perpendicular bisector of segment AB. We are going to be concerned about three basic symmetries: symmetry about the y-axis, symmetry about the x-axis, and symmetry about the origin. Again, let's consider a graphical illustration. Given any point in the plane with coordinates AB, the point symmetric to AB about the y-axis is the point with coordinates minus AB. The first coordinates are opposites and the second coordinates are equal. The point with coordinates A minus B is symmetric to the original point AB about the x-axis. In this case, the first coordinates are equal and the second coordinates are opposites. Finally, the point with coordinates minus A minus B is symmetric to the point AB about the origin. In this case, both coordinates of the 2 points have opposite signs. We can extend our notion of graphical symmetry from points to sets of points or curves in the plane. A graph is symmetric about the y-axis, provided that for every point xy on the graph, the point minus xy is also on the graph. A graph is symmetric about the x-axis, provided that for every point xy on the graph, the point x minus y is also on the graph. Notice that a graph with x-axis symmetry cannot be the graph of a function. A graph is symmetric about the origin, provided that for every point xy on the graph, the point minus x minus y is also on the graph. Given equations of curves, we can test for symmetry algebraically. To test for y-axis symmetry, replace x by minus x in the equation. If the result is an equation equivalent to the original one, then the graph is symmetric about the y-axis. To test for x-axis symmetry, replace y by minus y in the equation and see if you get an equivalent one. Finally, to test for symmetry about the origin, replace both x and y with minus x and minus y respectively. Simplify the equation and see if the result is equivalent to the original equation. When the graphs of functions have certain symmetries, we classify the functions as even or odd. A function is called an even function, provided that f of minus x equals f of x for all x in the domain of the function. The graph of an even function is symmetric about the y-axis. A function is called an odd function, provided that f of minus x is minus f of x for all x in the domain of the function. The graph of an odd function is symmetric about the origin. Recall that a graph that is symmetric about the x-axis cannot be the graph of a function. This is because the graph fails the vertical line test for a function. It is possible for a function to be neither even nor odd and lack origin or y-axis symmetry. Let's consider three examples in which we want to determine whether a given function is even, odd, or neither. We are first given the function f of x equal x cubed plus 2x. We will compute f of minus x and see if we get f of x minus f of x or neither. We plug minus x into the function, then simplify using the order of operations. We can factor out a negative And notice that we get the opposite of f of x. Therefore, the function f is an odd function, and its graph will be symmetric about the origin. Now let's consider the function g of x equal x to the fourth minus 4x squared. Again, we will compute g of minus x, simplify, and see what we get. We plug minus x into the function g, then simplify. Notice that we have g of x. Therefore, the function g is an even function, and its graph will be symmetric about the y-axis. Finally, let's consider the quadratic function h of x equal x squared minus 6x plus 5. When some students see in a quadratic expression, they automatically set it equal to 0 or start to factor. It's important to stay focused on the context of the problem we are trying to solve. In this case, we want to determine whether the function is even, odd, or neither. So we compute h of minus x. We plug minus x into the function h. Then we simplify to get x squared plus 6x plus 5. This expression is not equal to either h of x or the opposite of h of x. Therefore, the function h is neither even nor odd, and its graph is not symmetric about either the origin or the y-axis. This does not mean that the graph has no symmetry. The graph just doesn't display these two types of symmetry.